Everybody, and welcome to our web chat with the title Exploring the Role of Biochar in Mine Rehabilitation. And as you all are aware, biochar is a hot topic in the rehabilitation space, and every time we have our conference, it's one of the discussion points. And so, as an information sharing platform at LaRSSA, we are happy to present Charlie Cornish today, who is a co-founder of a company called Substrate Biochar, to come and talk with us about the opportunities of biochar in our country and also in the rehabilitation space. So Substrate Biochar is a company that focuses on project development and carbon removal using forestry waste in South Africa. But then importantly, they also focus on carbon project development and financing, and they're hoping that using that aspect will enable them to use the carbon revenues to make the biochar supply point a bit more accessible.
Thanks. And then I think... Sorry, go ahead.
Yeah, no, I just wanted to mention as well, one of the key things that we want to get to today is a discussion around the biochar development platform, where they are seeking partnerships and opportunities for research and trial development. So I think that will be a valuable discussion. And before I hand over to Charlie, I just want to mention you're all muted now. So if you have a question, drop it in the Q&A box. And then every couple of slides, Charlie will stop and we will take your questions. And then at the very end, we'll open up the mics so that we can have a constructive discussion. We're looking forward to that engagement. Thank you very much. I'm going to hand over to Charlie. Thank you, Charlie.
Thanks, Helene. Lovely to meet you all. Thank you so much for the opportunity to come and present to you. Just sort my slides out. Helene, is that showing as it should be?
Yes, it's perfect.
Fantastic.
Ready to go.
Fantastic. So, yeah, firstly, thank you so much for organising, Helene, Teresa, and thanks all for attending. As Helene said, my goal today is to talk a bit about, biochar carbon removal, which is how lots of these projects are coming together, how we operate, how we produce biochar. And then the second part really is hopefully the relevant part here. So biochar's role in land rehabilitation and how we can work together and how we would like to work together on that. As Helene said, I love lots of engagement, lots of questions. That keeps it interesting and allows me to talk about the things that are relevant for this webinar. So just let me know as we go. I think I can't see the questions, so Helene will kind of go through them as we go through the slides. So firstly, I want to sort of talk about who we are, what we do, and how we produce biochar. Hopefully that's of interest, helps kind of understand that side of the coin. So firstly, our team. So this is our leadership team here. Substrate's co-founded by myself and Oliver. So Oliver's a carbon markets expert. So he started off life at McKinsey, working on big sustainability projects for big corporates, and then moved to the Rockefeller Foundation based in Nairobi and set up a program called the Africa Carbon Markets Initiative. The goal of the Africa Carbon Markets Initiative is to work with African governments, help them develop carbon strategies and carbon market frameworks that support economic growth at the same time as reducing overall carbon emissions. So Oliver's real expertise is on carbon frameworks, carbon credits, and that whole market. Jaco on the right, our operations director, is a highly experienced plant operator. He spent many years building plants, commissioning plants, designing, optimizing production lines in Southern Africa, and has worked in a number of different industries. And Jaco leads our plant operations. Myself, I'm a civil mechanical engineer by training. I actually started out working with WSP, who I think are one of the sponsors of LaRSSA. As you can tell from the accent, I'm British. I split my time between London in the UK and our project sites in South Africa. I sort of lead the technical and operations work that we do, design the systems and the pyrolysis equipment, procure the right equipment for that, and particularly focus on the biochar applications. So I'll come on to that in a second. The rest of our team is built up locally to the project sites. So we have site 1, for example, in South Coast KZN, which I'll come to in a second, operates with sort of 15 to 20 people, from plant operators, material processing, so biomass processing, and particularly for us, for the carbon project side of things, a lot of monitoring and tracking. So collecting data on everything we do to prove the carbon sequestration potential of the biochar that we produce. So briefly on our company that I started to introduce. So our goal absolutely is a carbon removal focus. And so we exist to sequester carbon, and we effectively do that on behalf of large organizations, corporates, philanthropies who seek to remove carbon from the atmosphere. That can either be because that's part of their goals, or it could be because, let's say, a data center operator, for example, has a base load of emissions. Over the coming years, they are reducing those emissions, but for now, they haven't reduced them in their entirety, and so they offset the remaining portion with carbon removal. That's typically not their core area of expertise, and so they effectively outsource to a company like ourselves who perform that service. It's worth saying there are lots of other ways of doing carbon sequestration. You might know direct air capture, right through to reforestation, and relevant here, regenerative agriculture practices. For us, biochar is a very nice combination for carbon removal. It's quite evidence-based, so it's easy to track, monitor, and test, and validate how much carbon is being sequestered. It's quite cheap on the grand scheme compared to something like direct air capture, which requires extremely expensive machinery. I'll come on to it, but biochar can be done relatively simple machinery. And then the final part for us is just that it doesn't exist in in a bubble of carbon removal. As we'll get on to, it deals with a waste problem, waste biomass that's either burnt or just left to decompose can have a use. And then the end product, the biochar itself, has so many interesting applications. We will obviously dive into the effect on land, but right through to anything from land rehabilitation. People are using it for batteries, energy storage. It's a really interesting material, and so we see it as a very exciting route to do the carbon removal. So just briefly, the biomass that we use at the moment is sawmill residues. That's our main focus. That's a good point source of biomass, and the lower grade material typically doesn't have a use. So often burnt or just left to degrade. It's worth saying that depending on your machinery, it's actually possible to pyrolyze and produce biochar from a whole range of biomass, organic waste biomass. That could be anything from municipal sewage sludge, if you're brave enough, through to sugarcane bagasse, nutshells, alien invasives, a wide range. So it depends where you are, what your goals are. We then pyrolyze that, and I'll come on to the process and the technology to do that. And I suppose for us, it does vary a little bit, but for us, the products of our operation are firstly the biochar, secondly the associated carbon removal credits, and then thirdly, the process runs pretty hot, and so you generate lots of heat and electrical power that in the best settings can be used for secondary applications. So in the case of a sawmill, for example, they have a need to dry timber. At the moment, they use fairly simple steam boilers there are lots of exciting pieces of work that we're engaging on to reuse some of the low-level heat off the back of the pyrolysis equipment for a sawmill application. Where are we operating? So it's worth saying we're still a young company, and I don't want to pretend that we're further ahead than we are. We are currently building our first commercial site near Port Shepstone, South Coast, KZN. So that site will process about 10,000 tons of sawmill residues per year, produce around 3,000 tons of biochar per year. And we have the capability to scale that up over the next year about 2 or 3 times. As you will all know better than I do, the big forestry belt up the east side of South Africa, there's a lot of opportunities for further projects. And so we have some exciting pipeline projects in KZN Midlands and into Mpumalanga as well. Interestingly, just looking at this map, some of the best applications of biochar are on the west side of the country, particularly in the winelands and places like that. And I know big mining operations in the Northern Cape as well. So it's we'll get into the logistics of the operation, but there are some opportunities on that side of the country as well to develop biochar projects from our perspective. I'll pause briefly there. I'm happy to address any immediate questions of what we're doing, how we operate, and then I'll get more into the technology, how the pyrolysis works, and then onto the biochar applications. Helene.
Charlie, I don't see any questions at this point, so I think we'll can carry on.
Excellent. So next level of detail, I suppose, on how it works. And it's worth saying, this can vary. Different producers do this in a different way. I'm going to focus on our approach, which is an industrial scale process. And I'll explain the reasons that we are going about our biochar production in that way. There are obviously lots of other ways of doing it, right from converted charcoal kilns, Kontiki kilns. For us, this is the best approach. So I suppose starting at the beginning, mentioned the biomass. So we are looking for point sources of biomass. You get consistent material, and that allows us to produce a consistent biochar. You can obviously process other types of biomass and convert from, let's say, alien species. Each time you handle the biomass, obviously comes with a cost. So for large scale, integrating with a point source is definitely preferable, but we're always open to looking at other things. And obviously, alien invasive species is a real problem, right, in terms of land degradation. And so we are actively pursuing some opportunities there to see if we can make the model work. So we source our biomass, and then the first step is to dry it. So to produce good biochar on this type of machinery, you need to dry the biomass down from the kind of ambient 30-40% moisture content down more like 15%. So we have a dedicated drum that constantly progresses biomass through it and dries it at a low level of heat. Once it's dried, we pass it into our pyrolysis chamber. So again, this is a rotating drum. We preheat that drum to about 600 or 700 degrees centigrade with biomass inside it, and that preheat causes the initial volatilization, basically, of some of the organic compounds inside the biomass. That comes off the material as a thin gas, which I'll come back to in a second. But over, let's say, 30 minutes of pyrolysis at this temperature, in the absence of oxygen, we char the biomass and produce the biochar. And this is a process called slow pyrolysis. You can tune all the parameters and produce different kinds of char. Depending on your conditions, you can produce bio-oil or even wood vinegar for other applications. For us, it's all about the biochar, and so we will run our machines tuned specifically to produce as much biochar as we can from that material. Just touching on the syngas there. So one of the nicest things about biochar production overall in this way is that it's a very kind of elegant, self-sustaining solution in many ways. So the biomass is heated up, the syngas is produced from it, and we then burn that syngas to provide the heat for the ongoing pyrolysis reaction. We also use it for drying, so we direct some of that lower level heat to the drying system, and this is the bit where there's a potential to integrate with other industries. And so sawmills, for example, directly use that heat, and then there's also an opportunity to use what's called an ORC cycle, organic Rankine cycle, to convert that heat into electrical power. So those are all really exciting kind of secondary outcomes from producing biochar in this way and using that syngas sensibly. Once produced, we quench the biochar to basically stop the charring process, bring the temperature down, and then I'll get a bit more into the carbon side of things, but we essentially do a lot of testing on that material to prove the carbon content, the H to C org ratio, the stability of the material, porosity, any trace metals. So depending on your feedstock, you can end up with quite a high concentration of, for example, almond shells. I think you end up with quite a lot of aluminium. So very important to make sure you know what's in that material, particularly in a soil application, right? So more broadly, and we've called it the sort of biochar partnership platform or development platform. The way we see ourselves, we've got quite a comprehensive expertise across the carbon project development cycle. So starting with pyrolysis expertise, we've spent a couple of years basically refining the design of a pyrolysis system for this application, working with suppliers. So our machinery is Chinese manufactured. These companies have been producing pyrolysis systems for well over 40 years, initially just to deal with waste. So particularly for island nations who can't export their waste like some others do, pyrolyzing tires and things like this. So that's where the technology has been developed, and it's now being refined for this carbon removal application, which is very exciting. The second point here, basically connecting up the source of a biomass with a full carbon project around it. Quite a lot goes into that, from selecting the right standards to use, selecting the right technology, obviously, selecting the right biomass, and then ultimately finding buyers for the carbon credit that you produce. We have strong networks in the kind of financing space for this type of project, based on previous experience and building networks both in South Africa and in the UK and also in the US. And then I think the fourth point here is just we are absolutely on the ground. So our team combines that on the ground, hands-on, operating our own plants with the broader connection into the carbon markets, and we've built up quite a big bank of expertise in developing these projects, everything from the environmental side, navigating the EIAs, and bringing in technology, all this kind of the equipment, all of this kind of thing. And we haven't done that all ourselves. We've got a good network of partners and consultants who are expert in different aspects of that. Just quickly, while we're here on the sort of carbon side of things, I know lots of you will have experience with carbon credits already in different guises, whether that's biochar or forestry or agricultural type carbon credits. So it's a rapidly developing landscape out there. In the biochar world, selecting the right standard is quite important, as it is in any project, actually. The standard we use and operate with is called Rainbow. They're a France-based, Paris-based organization, and they effectively tell us, these are the rules for how to produce your biochar, how to produce your credits. And that is a third-party independent verifier of what we're doing. That allows us to create carbon credits that are defensible, and that gives the buyer of a carbon credit enough confidence in what we've done as an independent third party. There are lots of other standards. So you may have heard of Verra, for example, isometric, Pure Earth. In the coming years, I do expect some conversions. In the biochar space in particular, the underlying science is quite common across them. And so, it becomes quite a uniform, hopefully standardized in the future. Briefly, before I pause on and get more into the land rehabilitation side, for us, as I said, we're early in our journey. We're building our first plant in KZN, but for us, what to do with the biochar is a really critical aspect of any project. And I do understand I have a motivation here. We have to put our biochar in the ground before we can claim a credit, a carbon credit, and sell that. So it's obviously a key part of our project. What we, I think, do differently is work really closely to develop partnerships across these different applications. For us, it's almost the biggest, as I said at the beginning, one of the most exciting things about biochar carbon removal is the impact of all the end uses of the biochar. And so we're working as hard as we can to develop those use cases, support partners in developing them. It's a relatively early industry for sure, but we're excited to see where it goes. The 4 areas that we are looking to work with essentially. So the first one here, construction materials. Biochar has some really interesting properties that allow it to be used in construction, and that's particularly exciting because construction materials are normally what's called a very hard to abate sector. The emissions are very difficult to get rid of. So there's new development work in concrete mixes where you add some biochar instead of cement. You can get even the same or better concrete strength, whether that's in foundations, paving slabs, curbstones, things like this. So lots of interesting development there. Land rehabilitation, which we'll come on to, and you are all very knowledgeable on already. So we'll come back to that one. Probably similarly, agricultural soil improvement. So this is from the carbon side of things, the one that everyone sort of focuses on. For us, it's all about finding the right specific application. So biochar isn't right for all soils. In KZN, for example, sandy soils, you can have some really interesting, useful impacts on water retention and microbial activity, and get some very exciting yield increases, which I'm sure lots of you are familiar with. And then the final one, an interesting one, road surfacing. Biochar can actually replace some of the inputs to asphalt production. You actually get a more durable road surface, and you can apply it at a lower temperature as well. So lots of exciting opportunities there. I guess the key thing to say across all of these is that at the moment, producing biochar is expensive to do, and unless you bring that carbon revenue stream in, I think my understanding, at least in my view, is that the biochar is too expensive as an input material at this early stage. For us, what's really exciting is if you build a project using the carbon as well, you can reduce the price of that biochar really significantly. We reckon about 4 times lower, and that enables and opens up lots of different end uses, which is very exciting. I will pause there. Helene, if there's any questions, happy to address them, and then we'll get into more specifically land rehabilitation.
So still no questions, but guys, please think about some questions that you can post in the box or keep them for when we've gone through the entire slideshow. And you can post the questions directly to Charlie.
Perfect. Thanks, Helene. So focusing now more on land rehabilitation, I think the first thing to say is, as you can see, we are carbon project developers. We are excited and very eager and learning on land rehabilitation, but you are all experts here, right? And so I don't want to tell you more than you already know. I can't tell you more than you already know. This is, our understanding of the best applications, and actually, I would love to hear from you. What I've missed, what you see as the best or less good applications, different areas, different types of applications. That's what this is all about. So hopefully this sparks some thoughts, and then please come in with your expertise or your experience and knowledge of on the ground. So I think if I just cover the kind of issues that we think biochar can address, lots of these are familiar. And typically the problems that we're looking to fix when we talk about land rehabilitation. So compaction and low porosity of degraded land, a lack of carbon in the soil, poor water holding capacity, acidity from previous activities, whether that's mining or landfill or other previous activities that have led to that soil being quite acidic. Toxicity of metals, again, depending on the previous use, high concentrations of some dangerous metals and even PFAS and pharmaceutical residues from that I suppose applies in the water treatment world as well. Low vegetation, survival, difficult to get things to grow basically. And then connected to that, instability of soils and tailings in particular. I'll just quickly cover, what biochar can do in these different scenarios. So, first one there is it can be a liming agent depending on how you've made it, and it can increase the pH. It can immobilize some of these nasty heavy metals, PFAS, pharmaceuticals by absorbing them into the material matrix. Water holding capacity, again, highly porous material, so it can hold water, lock water quite nicely into the soil. You can convert a kind of dense soil into more loamy soil, reduce the density of it if that's useful to your crop or your end goal. Biochar can really help plants establish and survive more. And obviously we talked filtration of metals and pharmaceuticals. I think the key thing I want to mention here is it's not a silver bullet, and I think you'll all know that already. It's really important that the application is very specific to the end use and the scenario that you're trying to address. In agriculture, for example, sometimes if you apply biochar directly, you actually withdraw water availability from the plant because it's so porous. And so you have to do it in the right way. You have to charge it, microbial charging, for example, bacteria, fill it with water before you apply it. All these things are very important. And I think it's a critical part of any successful application is the right level of planning, obviously. So quickly, touching on our research and where we see some really interesting results here. Again, I can't claim these papers were written by me. I'm just going to briefly touch on different interesting results across some of the different applications to trigger some thoughts and interest. And we're very happy to share, our research in this space and where we see the exciting results coming after the call. So the top line here, so water and nutrient retention, the mechanism for this is just the high porosity of biochar. So I think some incredible 1 gram of biochar can have up to 400 meters squared surface area. I think that's the right kind of magnitude, but an incredible porosity in the biochar. That's obviously very helpful for absorbing and holding liquids. And depending on your goals there, you can increase purely the water holding content. You can apply that with nutrients, and also, if you're in a dry environment, you can just generally reduce your soil density. Esther and Marietta at iWater have run some field trials and achieved an amazing 19% reduction over, I think, only 5 months after application of soil density. So if that's something that you need to improve your soil, it can be a very powerful application. I mentioned, so number 2 here, I mentioned toxic metal leaching. So biochar is a very solvent material, or the right kind of biochar. It in the process of being made has you produce surface groups, I think they're called, positively charged surface groups on the surface of the biochar, and that attracts and holds negatively charged on the biochar, attracting positively charged contaminants. That's the mechanism it does so by. This is actually what's in any water filtration systems, even in the home. Biochar or activated carbon is sometimes called, used in those systems. Again, some interesting case studies and results that have been seen. So removal of an incredible proportion of, in this paper, cadmium, copper, chromium, lead, and zinc, 50 to 90% reduction there. So some amazing results across different applications. These are around the world, not specific necessarily to South Africa. iWater are working in South Africa and Southern African countries, so more relevant results there. The middle line here, so pH stabilization, particularly in acid mine tailings. Biochar can have a positive impact on raising the pH and stabilizing it over the long term. That obviously has lots of knock-on effects for further applications. Some results showing from pH 4 right up to above 7 using pine-based biochar, which is what our input material is pine sawdust. So some amazing results there. It's worth saying that the variation in application rates in agricultural soils, anything from 1 ton per hectare. Some trials land on maybe 5 tons per hectare. In mining remediation work, we've seen even up to 50 tons per hectare, and that's applied in layers. So put a layer down over time and then come back and add another layer. So real variation. That would be something to get right, obviously, figure out for the particular application what's most effective. Number 4 here, so cation exchange capacity, really relevant for agriculture. Obviously, I mentioned the mechanism, the high surface area, and the negative charging that you get when you produce it. This can hold nutrients very nicely in the soil. And again, iWater found some amazing increase in T value. So I think 2.7, a multiple of 2.7 in the particular soil. And I'm sure the team there can get into more detail on their trial, but that was a relatively short trial, 5 months, and some amazing results from that. Finally, the bottom line here, so revegetation, particularly on soil stability, for example, increasing vegetation, root activity can help stabilize particularly the top layer of the soil, and some amazing results, increase in tree survival using pine biochar. This is in a sandy application. That's a very quick overview of a kind of broad amount of research out there, but hopefully relevant to various different applications that you will work in. Finally, I just want to talk,
Charlie,
yes.
I was wondering if we could just pause there because we have 10 questions now.
Oh, fantastic.
I'm wondering if you want to take them or whether you want to finish off the presentation and then we open the mics.
I've got one more slide. Why don't I do it? let's finish that off, and then we can go to Q&A. I can cut the presentation and see everyone's questions and stuff. So
Okay.
Just finally, I think, how we see partnerships in this space. We're so keen to talk with experts working in this field. As I said, we're a small team. We don't have this expertise. We are eager to learn, and we are learning, but we're not real experts here. And so we're extremely keen, and this is why it's such a great opportunity to be on this webinar, to meet people, learn about their work, learn about potential for biochar applications, and move forward in that way. So just quickly, how we are working at the moment. We're building partnerships directly on the research side of things. We're funding our own trials, particularly in the agricultural side of things, but we were always looking for more, keen to work with students, university programs, and develop the kind of, particularly the economic use cases. I think there's a lot of scientific work out there, which is fantastic. Less so on the kind of economic routes to market, essentially. So that's particularly where we're looking. Secondly, I've called it expert network here. We are constantly meeting people and building our network of experts, advisors, consultants, researchers. I've mentioned two here. So Esther and Marietta Eyewater, we've had some great discussions with, and we believe are doing some amazing research there. And equally, Abigail at Life Green Group, doing some fantastic work. There'll be lots of others that I haven't come across yet. Obviously, we want to meet with you all. But I suppose in this sense, we, having already met and started discussions in this space, we as a biochar provider have the right partners, should that be necessary, to develop programs of land rehabilitation using biochar. Third thing here, I think, hopefully of real interest is, the way we're working. We are keen to really get field trials running, and we are able to support that both with highly subsidized biochar material for trials, and in some scenarios we will seek to kind of co-fund those trials and that field research with a partner. So if that's something of interest, we would really love to talk and get into more detail. Obviously, for now, our operations KZN, it doesn't preclude transporting the material to other sites further afield. Longer term, obviously, biochar production is a logistics game as well. You have to be near your biomass source, and you have to be relatively near your biochar application. So if in the Northern Cape, for example, the best way to do that would be to produce biochar there or source locally to the application. And then the final point is, I mentioned at the start our system, industrial scale. What that means is production of really consistent supply of biochar, both on volumes and on the quality. So we were able to produce something really specific to the needs of the application. We can evidence it very, very clearly. You know exactly what kind of material you would be getting. So that's my presentation. I'm really looking forward to the questions and answers. Happy to go in any direction, so please don't hold back. I'll pause there, and Helene, we can get into the questions.
Yeah, so Charlie, I think if you can navigate to that Q&A box and start at the bottom, because it loads from the bottom. And then once we've worked our way through that, I think we should let people raise their hands, and then we can open their mics.
Yep. So I'll start with questions from Hannah. So which carbon standard are you using? We are using a standard called Rainbow. As I said, for biochar production at this scale, there's a few leading standards now. And I say leading from a scientific point of view and from a market point of view, in our eyes. So those are probably Pure Earth. We've got lots of big projects live already. Isometric, a UK-based standard, who are very high integrity, high, quality data collection, all that sort of thing. And for us, Rainbow is our standard, used to be called Reverse. And for us, that's the perfect partner in biochar production in our setting. Second one, wood vinegar. So for us, depending on your temperatures and your residence time and also your biomass input, you can produce wood vinegar. For, in our setting, for the carbon project, we want to maximize the volume of biochar produced. And if you want to produce wood vinegar on our equipment, our type of equipment, you produce less biochar. So that's the simple reason. But there's many great applications of wood vinegar, and depending on your equipment, you might have it as a byproduct anyway. So it's not any reason other than that. And then we've got a question from Jan Nell, sorry. What are the main raw materials you use at the biochar plants? Is it continuous? Is obtaining a continuous source of material a challenge? So great questions there, Jan. For us, it's pine, so forestry residues, pine material. That's particularly the lower grade material that doesn't have a use already. So sawdust, saw shavings, offcuts, things like this. Continuous, our machinery is continuous, and the reason for that is it allows you to control the conditions for pyrolysis very closely. And for us as a carbon project, that's really important. We want to know exactly what material we're producing, and so you can set the conditions and maintain them much more easily. Is obtaining a continuous source of material a challenge? Depends where you are. It's obviously a critical part of any operation. In particularly the forestry belt on the south and east of the country, there is loads of material available, and that's what we've spent the last couple of years building up. Right, Gustav, a great question here. Can biochar deliver carbon sequestration benefits without worsening air quality during production or straining energy systems in power-constrained countries? Fantastic question there. So the first thing to say is it's actually an incredibly clean process. So I showed some graphics of our equipment. It looks like sort of heavy industry and you have a flue, but given the temperatures that we combust some of the organic gases, you actually have a really low amount of particulate matter, very low nitrous oxide, very low sulfur dioxide in that stack. And again, that's all about controlling your pyrolysis system, using an industrial system that you can operate in a very kind of efficient way. So air quality, no. And we've done a lot of work. You have to do a lot of work with any environmental authorization, particularly in South Africa. I'm sure it applies in other countries as well, on proving that. So we've done that to start off with, and then we continuously monitor, actively monitor the flue gas to check that that's not producing any negative air impacts. And then the final question on straining energy systems. So again, to deploy these industrial scale biochar systems, once up and running, they're self-sustaining, which is kind of the most interesting and elegant part of the solution in my eyes. You do combust some of the organic material, but the net impact is at least double the amount you combust, you are sequestering within the biochar. Hopefully that answers your question, Gustav. Marseille from Sibanye Stillwater. Are your kilns mobile? How would permitting work? Can you expand on Northern Cape? Great question. So our kilns are not mobile, but there are actually lots of companies working in the more mobile space. For us, building a high integrity carbon project depends a lot on your energy usage, beyond the heat that you generate. So you have some power, you have diesel emissions and moving material around. All of that is optimized by being in one place. But absolutely, if you're looking at biochar itself and producing biochar in places where it's most beneficial, there are some good applications of mobile kilns. One company I'd suggest looking at is a fantastic company, an MIT in the US and Indian-based company called Takachar. They are producing mobile kilns to work in communities, particularly in India, with rice husks, I believe. So communities bring their rice husks to a central machine that can be moved around, produce biochar that they can apply back to their rice growing fields. So it's possible, absolutely possible. How would licensing permitting work from a mining perspective? So I think it would be as anywhere else, for the biochar production itself, that's the main focus of the environmental authorization. And that's about your machinery, your site, previous uses, the particular setting. The biochar application, I think, it's an organic material that's been used for thousands of years. I think, obviously, in agricultural settings, you need potentially certifications of it, but in mining, I would guess, without knowing exactly, that not a huge amount extra permitting would be required. Question 3, Northern Cape. So we don't have a project developing in the Northern Cape. I know that there are some companies looking at it, particularly on the alien invasive species. We would be always interested to talk. Even a small project can come together. And by small, for us, probably a few thousand tons of biochar would be the lower end of what we're looking at. Hopefully that answers your questions there. Hannah de Villiers, does your facility in KZN require air emissions license? What does that entail? Yes, it does. So that entails quite a few components, and we've worked with an excellent consulting firm to help us with that, who are very local to KZN and the application there. So everything from the baseline air emissions in your area, so monitoring the baseline, building dispersion models based on the weather, the landscape, the climate, through to an understanding of our own machinery and modeling the emissions, comparing to the baseline, and then showing any mitigations needed. But as I said, the stack emissions are very low in general. Lisa, does the biochar denature or metabolize heavy metals, or does it just store the compound? Secondly, which substrates or environments is it not compatible with, e.g. arid landscapes? Yeah, so my understanding is it just stores the heavy metals. It doesn't metabolize them. For us, it's worth noting, for a biochar carbon removal project, we have to prove that material stays in the ground. I know that in some water filtration applications, for example, you use a material like this, you store the heavy metals in this example, and then typically they combust the material to get rid of it. That wouldn't work for us. It's got to stay in the ground and not be burnt. Otherwise, the carbon that you've locked away obviously returns to the atmosphere, and that invalidates the project as a whole. Secondly, which substrates or environments is it not compatible with, e.g. arid landscapes? So arid landscapes, it's particularly good, and sandy soils as well, particularly good. Some, here in the UK, we have particularly clayey soils, and it doesn't necessarily cause any harm, but its impacts are less strong, effectively. So, best applications in sandy, dry soils, arid landscapes. Hopefully that answers the question. Next, thank you for all these questions. They're fantastic. Keep them coming.
Yeah, they keep coming. So I think we've reached 10. So I think keep going, but
yep.
If our attendees can please raise their hands if they want to ask a question directly, we can do that too.
Fantastic. Keith's question, what information is available on the performance of biochar in anaerobic digestions / lagoons and its effect on methane output? Great question, Keith. So I know that there's a lot of work going into it, and biochar as a in anaerobic digestion can have some really strong impacts. Basically, improve the efficiency of the plant. It's not something we have looked into, so I'll be brutally honest. I can't add much there. Would love to look into it. The anaerobic digestion side. Lagoons, I think, if I may understand this incorrectly, but that would be kind of artificial wetlands, potentially, maybe in your question. It can be very effective in artificial wetlands, but particularly from the filtration side of things. Methane output, I mean, there are lots of other interesting impacts. So if you put biochar into animal feed, you can reduce methane from cattle, for example, quite strongly. So lots of further afield applications. For us, it's about finding a industrial scale and one where it's permanently retained in the soil as substrate. Rihanna, will biochar trap or remove sulfates from contaminated soil? So again, I think it has the potential to do that, absolutely, depending on the soil and the setting. You know, I would want to prove it first before saying yes, but my strong suspicion is yes. Estée Jordan, what is the current expected cost per hectare of rehab? So for us, you know, our model is to sell biochar, and so I can give a rough estimate for pricing of that, very dependent on where you are. We would be looking, you know, anywhere between 2,500 rand up to 4,000 rand potentially, and we would love to get that lower as we build bigger plants. But that's the kind of scale. So if we multiply 2.5, you know, around 100,000 rand, I suppose, up at the 40 tons per hectare, which I think would be a high end. So hopefully that answers the question. And then how would you define successful rehab from an area where biochar was used? I think, you know, it's no different to in the broader context, successful rehab, reduction in leaching, increase in stability, whatever your goal is, it's the same. I think for us, being able to demonstrate against a control and a non-biochar application and a biochar application to demonstrate that the biochar has had an increased impact for us is a success. So that's what we're looking for. Next ones. Sabuku, what traditional methods have you used to produce biochar that gave you the best quality product? So we haven't used non-industrial scale kilns, but there are lots out there. So anything from a charcoal kiln that's been converted to a biochar kiln. Effectively, you take some steps to ensure no oxygen is present, so the material just chars rather than burns. What's called a covered Kontiki kiln, for example, is used quite extensively in South Africa already. I can't vouch for the material that's produced there or the kind of net emissions that come off it. But there are lots of people doing it, so I'm sure that information is available. Muti, what's the correct application of biochar for rehabilitation? Can biochar be used to bioremediate hydrocarbon contaminated soils? Let's find out, I think is my answer. We would love to run some trials on this. Again, you know, you can find research papers that give you an answer of yes, but hopefully in the course of the last hour, I've shown that we really want to prove it in the real world rather than just wave a paper around. So I think yes is the answer, but would want to prove it. Rihanna Bait mining, utilization of lime trenches. Will biochar be cheaper than lime for use in trenches? I'm afraid I don't know the answer to that. Would be very happy to look into it and follow up afterwards. Next one, Rochelle. Where biochar is used as a remediation amendment, e.g. for metals or PFAS immobilization, what minimum monitoring period do you believe is necessary to demonstrate that performance is stable, durable, particularly before regulators would accept it as a long-term remedy rather than interim risk management measure? So again, I'll speak from the kind of biochar application point of view. For us, we have to prove that the material has been placed in its end use, whether that's a road, a concrete slab, a field for agricultural purposes, or in a rehabilitation setting. We need photo proof of that. We need operational proof, and then from a carbon perspective, I think it's a semi-regular follow-up essentially to check that has not been disturbed. But from a scientific point of view, if not disturbed, that carbon at least remains in place for even up to 1,000 years or more. From a land rehab point of view, I'm afraid I'm not the expert, and plenty of you already will understand, I think, more than I do about the performance monitoring from a regulatory land rehab point of view. Again, would love to learn more about that and see if we can assist. And then we have a question from Brendan. Wow, 8 questions from Brendan, so I'll address them individually. How does the temperature variation influence properties of biochar? So quite a lot. You can produce biochar anything from, let's say, 300 degrees C up to over 1,000. And by doing that, you really vary, as I said, the co-products that you make, the bio oil, which can even be used as a sustainable aviation fuel eventually, wood vinegar, syngas, all of these things, you tune the factors there. For us and our application and our goals, which is long-term durability, temperatures in the 600 to 700 degrees is producing the best biochar, the most durable, stable biochar. Some other factors can influence, the porosity of it. You can also increase the porosity after the event by, I think, taking another step, for example, to open up those pores, for example. Number 2, to which feedstocks? Our focus is pine residues from sawmills for now. I think optimizing for that and the supply that we have is our first step. But as I said, depending on future applications, there are lots of different biomass sources that you can use. You just want to be able to run your machine, let's say, for 6 months on a consistent feedstock, I would say, to get the benefits of having a really consistent process. Does the type of feedstock influence the properties of the biochar usability? Absolutely. So both on the amount of carbon sequestered and on the physical chemical property of the biochar, yes, it does. In our view, pine-based biochar kind of has the best combination of all of those aspects. But macadamia shells are a great input, sugarcane bagasse as well. So it really depends where you are, what your applications are, and how you run your pyrolysis system. Is it governed by temperature requirements? I think I've answered that one in the previous questions. Do you provide biochar amendment mixed designs, type of soil usability? So at the moment, we are working with partners to do that. So we're a fairly small team. We don't have that in-house. We are working with farmers local to our site to run trials. We have agronomists who are working with us as well to design those trials, make sure they're statistically rigorous, and we are very keen to publish and share those results, and that would influence mixed design, absolutely. Can biochar mitigate erosion and desiccation, cracks on the mining dumps? I believe absolutely. So kind of in parallel with the other impacts on revegetation, density, water holding capacity, I think it has strong potential there. Do you sponsor academic researchers? Yes, we We don't do that yet, but we would really love to. So please do connect if relevant. And then budget quotations rand per ton for different types of biochar. So as I said, kind of in that 3,000-4,000 rand per ton at the moment. We think that's lower than the traditional market price. We hope to bring it down more and more as we work more closely with partners. Lynn Whittington, what does the product look like? Once you get an understanding of the equipment required for handling the product. If I can show you. So so this is a pine sawdust biochar. It's a very fine black kind of 2 to 3 millimeter, very fine material. Other biochars, for example, wood chip biochar, you would see larger particles. So depending on your application, some people crush it to make a real dust. So starting with something like that sawdust residue biochar is beneficial. Others pelletize it or want to put it into pellets. So you can have hammer mills, you can do all sorts of things with it. But hopefully that answers the question. And in the agricultural sense, getting to either a pellet or a dust that can be applied is the typical route, or blending it in with a compost and then applying that in the normal way. What's the limitations of biochar in terms of its, Wendy, this is effectiveness in reducing toxic metal leaching? Is its performance metal specific, and can it be modified to improve the metal specific performance? So I think absolutely on all of these fronts. So well, I don't, depending on the application, I don't know the exact limitations. That's exactly the kind of thing we would love to prove and test in different applications and make really specific to the end use, and see how far the performance can go, basically. Let go. Have you done studies under dryland crop production essay? What was the impact of biochar in terms of crop yield and soil health? So we have not done this yet. We're working with farmers local to our plant as we ramp up our production. This is a key focus for us, and obviously crop yield is the headline result. I can't claim it, but others have seen 25-30% increase in yield across different crops, depending on your application. So we've got lots of ongoing discussions in Eswatini, actually, with the sugarcane production, and water usage is a massive, well, probably the key thing there. They consume and pipe and distribute a huge amount of water. So relatively small increase in water holding capacity can have a big impact. Equally on microbial life, applying in the right way, you can really boost microbial life of the soil and see similar impacts. So we want to work with people to demonstrate and prove out. I think those were a fantastic set of questions. Thank you, everyone, for engaging. I see one hand up, and that's the end of the list as far as I can see it. I see one hand up in the audience. Please go ahead.
Gawelu, if you can unmute yourself, I think it should work.
Apologies, I think between the mic and I pressed the wrong buttons. Apologies.
No worries, no worries. Fantastic. If there are any more questions, feel free to fire them here. If not, I go back to my sort of call to action. There are some in the chat by those things.
I copied the ones from the chat
Ah,
box,
fantastic.
over to Q&A, so
Thanks,
it should
Helene.
be fine.
Thank you, Helene. Yeah. Excellent.
Anyone
So I think,
else with a question?
fantastic. Well, if things come to mind after the event, as I said, we are really keen to. We have a question now.
Good morning. I don't know if you can hear me. Chair, can I come in?
Yeah. Yes, please.
Thank you. My name is Lahau Masaji from the Department of Agriculture. I just wanted to check if you have perhaps done some rehab work on mine dams where they were mining gold and platinum.
Yeah, not directly, I'm afraid. I've seen it
Okay.
in the literature quite extensively. And, you know, particularly in KZN, near our site, I know there's quite a lot of platinum mining activity. So it's something we're really looking into, and would be very keen to discuss in more detail, both from a, you know, departmental perspective and from a operational perspective. Absolutely.
All right, thank you.
Fantastic. Unless any other questions crop up now, I just want to say thanks all for your time and amazing engagement in the questions and the discussion afterwards. I really hope it was useful, giving you a background of sort of industrial biochar production, and you know, potential applications in your various different fields. All I'd say is we'd love to continue the discussion, so please reach out directly. Let me just put my email address straight into the chat if I can. There we are. And we would love to discuss further your specific, there we are, there's my email, your specific questions and needs, and go from there. So that's everything from me.
Thank you, Charlie. That was wonderful. And thank you, everyone, for your questions and the constructive discussion. Teresa will share a link to the recording, and I think we will also share the presentation and maybe with
Absolutely.
that Charlie's contact details, because I think there's lots of people with questions they would like to post to you directly. I'm one of them. So I'll reach out
Fantastic.
to you directly with that. Thank you very much, Charlie.
Please
and
do.
to all our attendees, thanks for attending. I'm going to end the event now. Thank you very much.
Thanks, everyone.